This is Pillar 2, Manufacturing Process Reliability. And as per the body of knowledge, what this is relates to maintenance and reliability activities, to the manufacturing or production process of the organization to ensure that the maintenance and reliability activities support and improve the manufacturing or production process. So what are we going to cover today? The first thing I want to do is go into where does Pillar 2 fit? And if you participated in the Pillar 1 webinar, that was heavily involved with the business practices. So we're just going to touch on that with just a little bit of discussion on where Pillar 2 fits in. Then we're going to talk about understanding operating procedures. And that's really about knowing what you're working on, making sure that you understand the production processes and systems that you're going to be interfacing and supporting. Then we'll talk about process improvement, and the tools and techniques that are generally used to identify opportunities to improve processes and then to actually improve them. And then we'll talk about change management and specifically about the management of change process. Not so much about the cultural issues, but the management of change process. And then we'll talk about maintaining processes. And those are really how do you stay on top of the process to make sure that your process is functioning properly. So let's get right into where does Pillar 2 fit. So maintenance and reliability must be coordinated with operations and other organizational functions so that you can best accomplish the mission, vision, values, and objectives of the organization. And if you remember from Pillar 1, when we talked about business and the way that a business works and how the maintenance and reliability function supports it, you remember we started out talking about the manufacturing strategy. And remember, the competitive strategy was whether your organization is cost competitive or whether they're a differentiation-based competitive strategy or a focused competitive strategy. We also talked about the identification of target customers and products, targeting a market share and pricing strategy, and that then determined what your product demand would be. In the manufacturing strategy, that's where we allocated production resources. We tried to optimize asset capacity, production asset capacity. We're looking at improving process reliability and rationalizing unprofitable assets. So based on that manufacturing strategy, we wanted to develop production targets. And those production targets then fed the operating plan. In the operating plan, we were mainly concerned with things like availability, throughput, and quality, or OEE. We're looking at increasing capacity. We wanted to produce at the lowest cost per unit, and we wanted to minimize variability and, of course, have higher degrees of quality and customer satisfaction. And when we satisfy the customer and do well, then our price and capacity info then feeds the marketing strategy and the cycle continues. So when we're in Pillar 2, we are in these bottom two, the manufacturing strategy and the operating plan. This is where pretty much all of maintenance and reliability directly supports these two activities. So I just wanted to take this minute and go back and circle back to make sure that we're all on the same page as to where reliable processes fits into this paradigm. So now let's kick off into understanding operating procedures. Knowing how to start up, operate, and shut down, how to analyze and troubleshoot processes and systems. And it also includes the methods for identifying, addressing, and documenting continuous improvement activities. So, operating procedures. In maintenance and reliability, our activities must be linked with product or service processes and procedures. The objective is to ensure that maintenance and reliability activities support and improve overall performance. There must be clear understanding of operational requirements. So we use things like process flow diagrams, process parameters, and quality specifications and safety so that we understand those operating requirements. Maintenance and reliability personnel must learn and understand the processes and procedures. We have the ability to identify defects, issues, and changes when we understand those processes and procedures thoroughly. And I'm talking not just of maintenance and reliability processes and procedures, but of the operational and support processes and procedures. The idea is to become expert at what the entire system needs to do so that we can be better at our jobs. We want to be able to make real-time decisions and adjustments to control and optimize the total process. So if you think across the board on operating procedures, initially we have to plan and evaluate processes. So we plan them when it's a new process or procedure that's going into place, or we evaluate them when we have changes that come along. We also have to monitor processes. Then we should be able to collect data consistently and collect the data consistently. We need to then be able to analyze the data. So when we talk about evaluating or planning and evaluating processes, what we're talking about are the processes efficient and effective? What can go wrong? Did we get input from all the different stakeholders to make sure that we have the full picture? Do we identify inadequate processes? Did we document any deficiencies? And did we categorize those deficiencies in terms of cost, benefit, and risk? When we're monitoring processes, we want to include include departments and other groups that might be affected. We want to trend historical information. We want to evaluate and monitor successes and failures. We also we also want to identify whether something can be monitored or measured that would give us better information. When we talk about consistent data collection, we want to collect consistent data in a timely and accurate manner. Poor data means poor decisions. And we want to use industry standards and benchmarking where appropriate so that we know how we're doing relative to those data that we're collecting. And we also want to have want to remember that accuracy is much better than quantity. It really doesn't do us much good to collect a lot of data if we can't trust the data. And so when we talk about data analysis, we want to strive to understand and improve performance. Raw data has no benefit if we don't analyze it. And data analysis identifies process and procedure strengths and weaknesses that we can then use to improve our processes later on. So what are some of the things that we do when we're working with operating procedures? Process flow diagrams. These are visual representations of the process. You might also use the name process mapping or flow diagrams. They can be used for training, for identifying waste and bottlenecks as well. So when we create a process flow, this is a great tool when we have new people coming into the facility for their orientation training. It also helps us to identify where waste and bottlenecks are, because when we have a cross-functional team looking at process flows, different perspectives may help us to identify where we can do things better. Process flows also help us when we use cross-functional teams, because that promotes communication and teamwork among the stakeholders and among those that contribute to the organization's mission. Another tool is statistical process control. This was a tool that was developed for quality control, but it can be used in other areas. It uses statistical methods to understand process parameters. And there are software tools that are available that help to simplify the task. In-control processes provide the greatest benefit. It leads to problem identification and elimination. Next is process parameters. It's an essential part of the process management and control process. things like flow rates, temperatures, pressures, and so forth. These are the things that are needed to be specified, monitored, and trended. It should specify operator intervention actions as well. So if temperatures or flow rates or pressures are off, what is it that an operator should do? We want to be able to collect relevant information so that root causes of deviations can be identified and corrected. Data historians and DCSs, or distributed control systems, management information systems that allow us to collect data and store them, allow us to look at patterns. And that's very important for improving our processes and standardizing the way that we operate systems. Risk identification. This is another tool. We want to be able to categorize risks, and the common ways that we categorize it are by safety, environmental, financial, operations, asset health, and goodwill. But you can categorize any risk that is important to your organization or to your work center. We should use cross-functional stakeholder teams to quantify credible risks. We should create risk controls to eliminate, reduce, or mitigate risks to a tolerable level. Now, there are also ways, if we can't reduce it to a tolerable level, there are ways to address risk as well through increasing the type or frequency of inspections. We could modify procedures. We could do things like carry more spare parts. We can budget for the consequences. We could transfer risk to third parties, like contractors or insurance policies. There's also a thing called a risk register, and risk registers are ways to record, prioritize, and manage risk within an organization. Risk can be ranked by likelihood, consequences, and detectability, and they should be frequently reviewed and updated to keep the organization focused. And when we prioritize these, we know where we're going to expend our efforts on trying to mitigate risks. Quality management systems. This is a means to define process requirements and to evaluate them at set intervals. We want to identify and remove barriers. We want to consolidate steps and minimize disruptions. Quality management systems help us to document processes and procedures, and that way they can also become a reference. And I talk about this all the time. When we document our policies, plans, processes, procedures, and measures, it becomes a reference. So if there's something that a team member doesn't do frequently, they can always go back and check that process or procedure. If there's a disagreement between different parties, we can use that document as the one version of the truth as to how things are supposed to be done. Helps to eliminate ambiguities, gaps, and overlaps. We also want to have attentive and assertive team members and leaders that can assess and improve those quality management systems, those requirements that we document in policies, plans, processes, procedures, and measures. ISO 9000 is an international standard for quality management. It focuses on detailed process documentation to optimize product or service quality. And it implements verifiable quality controls, documents processes, procedures, and ensures appropriate emphasis on quality. It also signifies that management is committed, involved, focused, and accountable. And we'll talk a little bit more on ISO 9000 in the next section. And here we are in the next section, process improvement. In process improvement, what we want to do is focus on maintenance and reliability's participation in manufacturing and production processes to facilitate continuous improvement. And there's a couple of blurbs that I took right directly from the body of knowledge that I felt were important in this concept. So this is the key to establishing and sustaining improvement techniques is to involve people who are responsible for work and who own, operate, maintain, and support the process. This heightens the sense of continuous improvement and nurtures a culture of empowerment, discipline, and accountability. Process improvements must align with the business plan and goals and include sustained workforce excellence, quantitative organizational performance assessments, and ultimately customer satisfaction. To create process improvements, organizations adopt various standards, processes, and tools. So one of the core concepts is the concept of zero defects. And when we talk about zero defects, it means that ideally organizations should strive for zero defects. And that means the elimination of defects will increase process efficiency. It requires a dedicated and skilled workforce. So that means there has to be robust training and resources that are made available for defect elimination. A good workplace environment helps with zero defects. When we have lower turnover, we also therefore have more continuity, we retain more knowledge, and we have more experienced people that are continuing to work within that facility. There's fewer defects or fewer mistakes. And we'll talk about a lot more of this in Pillar 4 under Organization and Leadership. But we also have more effective troubleshooting and improvements because we retain knowledge and because we have more experienced people. So what are some of the tools we use for process improvement? So some of these are processes or methodologies, and some of these are tools. And so the first one is total quality management, which we touched on earlier. This is the ISO 9000 series quality management system standard. And it's an approach for delivering high quality products and services. Again, it emphasizes on the quality of product and services and trying to delight the customer. So this is driving the organization towards being the provider of choice to the customer. Another methodology that's used is total productive maintenance. It promotes cooperation between maintenance and operations personnel. It encourages asset management best practices, and it fosters co-ownership, communication, and teamwork between maintenance and operations. Operations team members learn to perform basic equipment care, cleaning, and maybe some lubrication. It leads to efficient and reliable operation and processes. And the ultimate goal is to have no breakdowns and no accidents. And again, with total productive maintenance, when the operations team can take over some basic equipment care functions, it frees up the maintenance personnel to do higher level or more of planned maintenance activities. Six Sigma. This is a set of tools to achieve stable, predictable process results. It focuses on achieving measurable and quantifiable financial returns for each project. Processes have characteristics that can be defined, measured, analyzed, improved, and controlled, what's known as DMAIC. And there are specific Six Sigma tools that are applied in each of these areas. So sustained quality improvement through commitment and the entire organization. And just so this puts it into perspective, what Six Sigma means is that we have only 3.4 defects per million units. So just another word on DMAIC, the define, measure, analyze, improve, and control. When you think about DMAIC, think about that as more of a phase map. It guides the Six Sigma process. But I want you to know you can also use this DMAIC methodology or this phase map. You can implement it as a standalone quality improvement process. You don't have to necessarily have, go through the whole Six Sigma certification process. You can just use the same tools. Lean. This is a method for identifying and eliminating waste. Waste is found through overburden, unevenness in workloads, or a lack of uniformity. Lean focuses on using value stream maps that help you to visualize process steps and to identify improvement opportunities. 5S. This is used to eliminate waste, and the 5 S's are to eliminate waste by sorting, straightening, shining, standardizing, and sustaining all that has preceded. A lot of organizations have gone to 6S now, where the 6th S is safety, and that's in recognition that safety is foremost for most organizations. So a lot of organizations have decided to go to 6S instead of 5S. Root cause analysis or root cause failure analysis. This is identifying the root causes so that they can be eliminated either by re-engineering a policy, a process, or procedure through training or administrative controls. Process failure modes and effects analysis. This is very similar to failure modes and effects analysis for equipment, except we're doing it on a process. And this is where we use a procedure to identify ways that a process has failed or might fail, and the failure effects on the process. It's recommended that you use criticality, because criticality can be assigned to the effects within the process to denote their importance. And if the analysis is done during the design phase, then errors can be identified and designed out of the process before you go live with that process. Pareto analysis. This is also known as the 80-20 rule, and the principle behind it is that 80% of problems will originate from 20% of the assets or sources of problems. Key performance indicators. These identify critical measures that influence business goals. We want to specify by type of measure, how it's calculated, how often it's calculated, and with what precision. KPI data must be easy to collect, and it has to be consistently collected, and it has to be meaningful. Here's another thing called a balanced scorecard. This is basically a conglomeration of KPIs that provide an overview of organizational performance. It's used to articulate a successful strategy based on measurable performance, and typically it uses financial, human resources, operations, and environmental health and safety areas as that conglomeration of KPIs. Okay, so let's go on now to change management. And central to the idea of change management is the concept of having a management of change process. And this is a process that's used to assess, define, authorize, resource, train, and implement improvements. It should provide a line of sight for proposed or actual changes. In other words, you should be able to look at all of the proposed changes that are in the pipeline and what their status is. It applies whether it's a temporary change, whether it's a pilot or prototype change, or whether it's going to be a permanent change to the way things are done. It ensures that production, reliability, quality, safety, health, and environmental risks are all considered. And it maximizes productivity of manpower, coordination of activities, and efficiency of implementation efforts. And this is because we use the management of change process so that we don't have everybody deciding to run off and do changes that they feel need to be done. We want to do it in a coordinated way so that the limited resources, money and people that are available are applied to the most important changes that we want to consider. So it's a way to reduce waste, and it helps us to make sure that we're efficient at how we're changing. When it's properly employed, management of change adds to organizational stability, the accuracy of technical information, and the proper test and evaluation of those changes that are put into place. And I'm going to make an actual more definitive point about the technical information. A lot of times when changes happen, if we're changing an equipment configuration, for instance, or a type of material that's being used, how many times have you tried to find a drawing and found out that the drawing was not up to date, or that the documentation of how a system is assembled or some other aspect, technical aspect, hasn't been done correctly? A good management of change process will make sure that whatever the changes are, that those changes are not just documented into a process or procedure, but those changes are also documented in the technical information so that we can go back and check on that later. So another way to look at change management, I want to just use this little diagram. And so change management, when you think about it, what we want to be able to do is compile information. So there's something that we want to change. So we want to compile information about that thing that we want to change. We then want to develop the responses. And the response means what is the change that we're going to contemplate. So we want to develop what that change is going to look like. We don't want to just then authorize the change and put it into place. We want to evaluate that response. We want to make sure that we have others, stakeholders in the organization that are looking at it. And then it's very important to authorize the change, because the authority to approve the change has to come from an accountable person. We can't have 20 different people authorizing changes all over the place. So we need it to be a very formalized authorization process. We then also have to document, resource, train, and implement the change. So let's go through these. When we compile information, again, what we want to do is collect technical information, quality, customer requirements, environmental health and safety, and any other information on the products, equipment, materials, or processes that we're looking to change. Then when we develop responses, we want to request participation from stakeholders. We want to explore the impacts of possible solutions and the potential cascading effects, the unintended consequences. And we also want to incorporate feedback into our proposed changes. So in this phase, we might have 2 or 3 proposed responses, but we want to whittle them down to what's the most appropriate. Then we want to evaluate responses. And when we evaluate them, we want to ensure that all affected regulations, policies, plans, processes, procedures, and measures are considered. And we always want to check the risks and the business case. And if everything looks suitable at that time, then we can authorize the changes. And the authorization has to come from the person that is accountable for the implications of the change. Changes can only be authorized at the appropriate level in the organization. Then we want to document the changes in an official format, and we want to publish it. We want to make sure that we're able to allocate or reallocate resources as they're authorized. And we want to be able to train everybody involved. We want to implement and drive to common practice. It does us no good to authorize a change and then not be able to allocate the resources or the training that's needed for people to then implement that change. So this is a critical step as well. So what I say is that this whole process can be thought of as 4 different phases. I think about assessing, that's looking at strengths, weaknesses, opportunities, and threats to prioritize, filter, and decide which opportunities that we're going to go after. Then the develop responses and evaluate responses is really how we define those responses and what we're going to do to change. Authorize changes just means that. It means that we have the right accountability and the right level of authorization, and then we implement. So hopefully this model pulls it all together to you on what change management is and what are the different elements that come through change management. So what are some of the tools and processes that we use for change management? Well, one of the big ones is process safety management. This is an OSHA-required management system that addresses hazardous conditions, and most especially for chemical hazards. And OSHA, of course, is the Occupational Health and Safety Administration here in the US. This provides an analytical tool that aids in preventing releases of hazardous substances. Hazardous chemicals can be toxic, reactive, explosive, or flammable. And the goal is to decrease the number and severity of actual or potential hazardous chemical releases. There are various facility types that PSM applies to. They can be petroleum refineries, explosives and pyrotechnic facilities, even small businesses and storage facilities, and there's others. But if you wanted to check it out, the process safety management of highly hazardous chemicals is found in a standard 29 CFR 1910.119. And this is, of course, all for the US. Other countries have their own versions. Another thing that's more on the tactical level, day to day, there can be a thing called a manufacturing change request. And this can originate from anybody in the manufacturing team. It identifies a specific problem, and it should also propose a modification or solution that changes a manufacturing process, procedure, or equipment configuration. Again, this is a request. This is not authorized. This is where somebody in the plant identifies something that they think should be changed, and they submit the request. That request then has to go to an accountable person. A manufacturing change order is a manager-originated or approved change request. So the manager or that accountable person can decide that they're going to initiate a change order, or they can look at a manufacturing change request from somebody else and decide to go forward with that or to authorize that change request. It officially describes the authorized changes or modifications to a process, procedure, or equipment configuration. And again, this is an important aspect, is the authorization has to come from the accountable person. We don't want to have many people making decisions and making changes. We want one person to be accountable for those changes. So now let's talk about maintaining processes. And again, from the standard, from the body of knowledge, this is ensuring that maintenance and reliability activities are properly carried out to support and improve the manufacturing or production process. We need to comply with regulatory requirements, industry standards, and best practices. Examples include federal, state, or province, or local environmental, worker safety, product safety, etc. So this is kind of a diagram where we can think about how this maintaining process works. So we start out with requirements. And again, these are the policies, plans, processes, procedures, and measures that communicate what is to be done, by who, and with what. But we then have to provide the assets, the personnel, tools, equipment, parts, etc., and the training and skills development so that people are capable of executing or carrying out the requirements. In the execute step, we have team members that are applying assets, training, and skills to execute their tasking. But we also have leaders that need to be attentive and assertive in requiring conformance with those requirements. We then start to compare the maintenance and reliability metrics and performance with those requirements. We also want to be giving feedback on performance. So that feedback goes back into the execute phase. And as we modify our execution, then again, the measures and data tends to change. as we collect those measures and data, we start to become aware of strengths, weaknesses, opportunities, and threats that can then improve the requirements. So maintaining processes, we also have to consider regulations. Again, in the US, there's a thing called the Code of Federal Regulations. There's the Occupational Health and Safety Administration, the Environmental Protection Agency, and the Department of Labor. These are some of the more important and more commonly known regulatory agencies. In other countries, we'll have similar regulatory agencies. And regionally, within other countries or areas of the world, there will be regional, state, or local regulations that often complement or supplement the federal level regulations. So organizations need to continually keep their team members fully knowledgeable and attentive to these regulations. And not just that, but they also need to stay informed on developing or proposed changes to ensure that they're properly prepared. And so some of the things that we use to make sure that we are maintaining our processes is benchmarking. And so benchmarking is a comparative analysis among organizations that are similar. They could be within a business group or within similar processes that have similar processes and performance metrics. What we want to do is monitor defined performance metrics, and some of the more commonly used ones are things like unit cost or cycle time and productivity. We want to make comparisons so that we can identify the relative performance among peer groups. And it can indicate differences in guidance, assets, or execution that we can then pinpoint and improve. For individual organizations, you can also use gap analysis. So this involves a comparison of actual performance with potential or desired performance. A gap occurs when production or performance is below the performance capability. If an organization does not make the best use of its current resources or forgoes investments and improvements, it will perform below its idealized potential. So when we talk about maintaining processes, one of the things that we want to be able to do is set goals. And one of the commonly used ways that we set goals is to use a thing called SMART goals. And SMART is an acronym for specific, measurable, attainable, relevant, and timely. And when we talk about specific, what we mean here is what we want to do is define precisely what it is that we're trying to achieve. The more specific that you can be, the greater the chance that you'll achieve that goal. It needs to be measurable. That means that it's quantitative, not qualitative. We want to be able to identify the specific observable parameters when the goal is reached. It should be attainable. We should make it a stretch goal, but we shouldn't make team members or individuals stretch too far. It has to be viewed as doable. And goals must not discourage team members. It must be possible, but it shouldn't be too easy. It has to be relevant. Why do you want to reach this goal? What is the objective behind the goal? And what will the goal lead to if we achieve it? And timely. When should it be achieved? It depends on the nature of the goal, of course, but it could be a daily, a weekly, monthly, quarterly, semi-annual, annual, could be a 5-year goal. But without a time frame, there's no pressure to accomplish the goal. So if we want to improve, improve our maintenance cost per unit produced, we don't want to just say we want to improve our maintenance cost by 5%. We want to say 5% this year or within 12 months. So when you're setting goals, the first thing you do is select one or more of the measures that we want to track as a goal. We then have to define where the data for the measure will come from, how it will be calculated, and how often it will be measured. Having these standards in place make it harder for different business units or different groups to game the system. If you have one methodology for how we collect the data, how we calculate it, and how it will be measured, then it's much harder for people to game the system. Then we want to describe how the measure is specific, measurable, attainable, relevant, and timely. A few points about this is that when you're selecting goals, let the team help to determine what the goal level will be. Encourage the team to set a stretch goal, but make sure that the goals are difficult, but that they're achievable. In all likelihood, they're going to set a goal that's achievable, but in real terms, they often exceed the goal that they set themselves. So when they do meet or exceed the goal, ask them to set the next goal. And when they gain confidence with each success, they'll get more and more proficient, and they'll be wanting to set more aggressive goals. So this concludes the manufacturing process reliability, Pillar 2 discussion. I'll go back and recap here. So remember, we talked about where does Pillar 2 fit? And remember that triangle diagram between the marketing strategy, manufacturing strategy, and operating plan. And what we're really talking about for manufacturing process reliability is the bottom two areas, the manufacturing strategy and the marketing plan. When we talked about understanding operating procedures, the most important thing to take away from that is we want to make sure that we understand the systems and the processes that we're going to be assisting. We want to make sure that we understand them so that we can contribute better to solutions, to identifying where problems are, and to help the operating community succeed. We want the total operating program to succeed. So the best way to do that is by understanding the operating processes and procedures to the best of our ability, and not just the operating procedures, but also all of the other support procedures. And then process improvement. We want to be able to identify where there are defects in our processes. We want to be able to identify how to rectify those things. We want to look at, remember we talked about process parameters, making sure that those parameters are documented and well known so that if there's a deviation, we can identify those deviations. We talked about change management and two specific paths there for more strategic things, the management of change process that apply to whether it's a temporary change, a prototype or pilot change, or whether it's a long-term change. We want to have a system that allows us to manage that change so there's transparency, and so that we're focusing our efforts so that we can be efficient and effective in how we manage change. And then more of a technical level change, the idea of having manufacturing change requests and manufacturing change orders, so that as things come up, we still control the authority to actually authorize those changes. And then maintaining processes, we wanted to make sure that we have the tools to be able to benchmark, to do gap analysis, and so forth, so that we're paying attention to things like regulatory compliance, and we're making sure we're setting proper goals to make sure that we can achieve those goals.